Dear students, today we are going to discuss about the remaining types of the beams, which are continuous beam, overhang beam and loads, and we will also see the recap. Today we are going to learn about a few types of the beams, in which we are already learned about three types of the beams, that is simple supported beam and cantilever beam, fixed beam. We are already done. Today we are going to discuss about the continuous beams, overhang beams and truss beams. So we learn about the simple supported at both sides of a beam. Then it resists only vertical, it only resists vertical loads. When both sides of the beam only simple supports are there. If it has one hinge support at one end of the beam and one simple support at the other end, that might be a roller or simple support, then it resists both vertical and horizontal. It can resist the both vertical and horizontal, both it can resist. Similarly, for the cantilever beam, which is at the one end only, it has the support. That support is known as fixed end support, and the last end is known as free end, where there is no support is there. Due to the fixity at one end, it can resist the all the translatory forces and vertical forces also, and rotation. In addition to those horizontal and vertical forces, it can also have the resistance towards the rotation or moment. It has that of capability due to the fixity. So this type of a support and that results to the a beam is known as cantilever beam. For the beam which has at both the ends, if we have fixity at the both the ends, that means both ends are having fixed ends, then that beam is known as fixed beam. So it can resist at both the places horizontal forces and vertical forces and moment. Hence, it can be more advantageously used for the inclined forces and heavy loads, and where we want some rigid type of connections. In that situations, we are going to be used for these type of connections, where at one end is also fixed and other end is also fixed ends or the fixed supports. So it has a good advantage over the other types of beams. Today in this session we are going to learn about the another types of beams. Those are continuous beam, overhang beam, single overhang beam, double overhanging beam, truss beam. And we are wanted to a little bit about the introduction of the loads also. So before understood about the continuous beam, I want to explain about the span of a beam. A span is nothing but a distance between the two supports. Distance between the two supports is known as a span. So you can see here it has the span. So it is a support. This is the support 1 and this is the support 2. So between two supports, the distance is known as the span. In spans also there are different types of the spans. Hence, according to our design parameters, we will going to use the span nomenclature. The first type of the span nomenclature is clear span. Clear span means inner to inner, inner to inner. So if I say that inner to inner means this is the inner portion, this is the inner portion. For a support, this is the inner portion, right? So if it is that, then what is the outer portion? So this side is outer, this side is outer. So this is known as inner portion and outer portion. So this is outer and this is inner, this is inner. So if I said that inner to inner means from this point to this point, the span is known as inner span or clear span. So inner to inner is, we are saying like that. So this term is generally known as clear span, right? If I wish to take the center to center of the supports, in some cases you can also take this as a span. So this is the center to center. If I am able to write a line here at the center of the support, so you can see here, you can have a line. This is the center of this support, and for this support also you can have the center. So if I said that the distance between these two is known as the center to center span. So this is center to center span. And when I want to know about the outer to outer span, so we have to take this outer to outer from this point onwards. We have to take this distance. This is outer. This is the point of outer, and for this support also, this is the point of outer where you have to draw the outside point. This is the point of outer, and from this distance, this is known as outer to outer span. So we understood now there are in generally three types are we are using, that is clear span, that is inner to inner of a support, and center to center means we have to take the half of the support to the another half of the support, that distance is known as center to center. Outer span means it is outside of all the outside of the supports is known as outer to outer supports. In addition to this, one more span we generally across from the codes, that is saying that effective span. This effective span term is majorly used for the designs to analyze the structures. Right? So the distance of the effective span, sometimes we will term it as a center to center, it might be a center to center, or it might be as per the code mentioned in the IS code, as per the different types of supports it might be vary, and some other parameters of the loading conditions also it changes, the width of the support, type of the support, these all determines the your effective span. So I think it is clear. There are four types of the spans we generally talked about. One is clear span, that is inner to inner. The second is center to center span, that is the half of the support to the another half of the support. The distance between the both half of the supports is known as the halfway of the supports is known as the center to center span. Whereas for the outer to outer, it is completely beyond the support's outline to the another support outline. So that distance is known as outer to outer span. But in engineering, we generally use it for the design is effective span. Sometimes we will take a center to center span as a effective span, and it might be vary according to the type of the support and type of the loadings are there, width of the depth. So those all are depends upon how we have to take the effective span. Those details have been covered in your IS code. So we need to refer the Indian standard codes for this effective span of the corresponding design structures. Now we are coming for the next type of the beam, that is continuous beam. Still we are seeing only one span of the beams, but continuous beam is extending over more than two supports. That means it has many number of spans. It is not the only one span. It extends over the it is extending over it is extending over more than two supports. That means more spans are there, more spans. So that is important. So at that time what we is in simply supported beam has only one span we see is that, and cantilever beam also we see in only one span, fixed beam also we are seeing only one span, but now continuous beam has more spans. You see here, I will show the figure how it will be looks like. See this type. So it has the more than two support number 1, support number 2, support number 3. It has more than two supports, right? And spans also, if you see that this is the span 1 and this is the span 2, there are two spans, right? So more than one span, hence it is a continuous beam. More than two supports, hence it is a continuous beam, right? You can see, you can change have the different type of supports can also combine together for the continuous beam. Here in the first figure A, we have only simple supports or roller supports. In this figure we have shown only simple support or roller support. In the figure B, it has another combinations, like it has a fixed support. In one end it has a fixed support, the other spans are having only simple supports, or it might be a roller support, or it might be hinge support. You can here also we can have some hinge support also we can have. So that the option we can change for as per the requirement of the supports. And these spans, if you count here the spans, this is the span 1 up to this support, span 1, right? From this point to this point it is the span 2, this is the span 2. From this point to this point it is a span 3. So for this beam there are three spans, hence it is a continuous beam which is having more than two supports and or more than one span, then it is known as a continuous beam. So see the figure C also, where it has the how many number of spans here? There are two spans. Here you see one span, this is the one span, and from here onwards to here onwards it has the another span. Therefore it has the two spans. How many number of supports? Support 1, support 2, support 3. There are three supports. And in addition to that, the type of support is a combination also. Here it is an hinge support, we have the hinge support here, whereas here it is a simple supports, or you can say roller supports. So these type of combinations we are having to frame a continuous beam. So hence a beam extending over more than two supports, or it has more than one span, is known as continuous beam. A continuous beam is one having more than one span and it is carried by several supports. That is another definition. So the distance between two supports of any two, the distance between supports of any two might be equal or unequal. See this, what it is saying that the spans might be different. You see here, the distance between these two supports is very huge, it is large span, right? Whereas you see the distance between these two supports, it is very lesser, right? So this might be 1 meter, right? This might be 1 meter. So here it might be 4 meters. So that is the difference. We have the spans difference. So these spans might be different for the difference also. For this span it might be 2.5 meters. So this is the situation. We have the spans can be unequal. What it is saying, that the spans will be unequal, even though that is, if having number of supports are more than 2, then it is a continuous beam. So that is what he is saying, that the spans might be equal or unequal. So can you identify the continuous beam from this building which is under construction? Yes, you are right. This is a continuous beam. You see here, it is a continuous beam. It having the supports. You see here, support 1. This is the S1 support, and you see here, where is the another support? Here, S2 support, and you see here it is S3 support. So there are 3 supports are there. Hence, it is a continuous beam. Right, similarly you can also, the other side also, you can see that other side also there are number of supports. These are support 1, support 2, support 3, support 4, support 5. So this is a continuous beam. If you see, this is also a continuous beam. So this is also a continuous beam. You can see that this is all. And similarly here also we have the continuous beam. So you can have the plenty number of the continuous beams. So if you watch it here, you can identify in a multi-story building we have the number of continuous supports. So hence continuous beams are more used for the building construction. So please remember, these all are continuous beams, right? So can you identify the continuous beams in this figure? Yes, obviously. This is the support 1, support 2, support 3, support 4. It is a steel beam structure, right? In this also we have the continuous beam. You can see this. This is the continuous beam. So support 1, support 2, support, like span 1, span 2, span 3, span, right? Here span total 3 spans. If you see here, uh, if you see the above structure where it has the above floor, it has the more number of supports. Support 1, 2, 3, you can see here 4, you can see here 5 supports, 6 supports, 6 supports, and the spans are span 1, span 2, span 3, span 4, span 5, like that. So it is a continuous beam. So coming to the another type of beam, that is overhang beam. From this figure you can understood, from this figure it is hanging, the beam of some portion of the beam is hanging without any support. Here there is no support, or it is known as a free end. What we know, that at one end it is the free end. So one end is free end, without any support it is hanging over. That's why it is not the cantilever, it is a free end, right? Cantilever requires a fixed support. So please note that if it is a cantilever portion should become, then it requires a fixed end. But here it is a simple support, right? And come to the what is a overhang beam. So what he is saying, that a simple beam extending beyond its support. So this is the support portion. Now this beam is extending beyond. So beyond support the beam is extending at on one end or at both the ends. So it can extend beyond this support is known as single overhanging. If it also extends the other end also, then it is known as double overhanging. That means it has a single overhanging type of beam or double overhanging type of the beam. If it extends both the sides of the supports, then it is a double overhanging beam. If it extends only one side of the beam, then it is a single overhanging beam. So the requires what type of supports is required? It required fixed or hinged support. Please remember, if a fixed end comes, it is a cantilever portion. So I had given for that another name. If one end is fixed, then that portion becomes a cantilever overhang. We will see how it will be adds. Right? In the overhanging portion, cantilever is going to be add due to the fixity of the one of the support, where the beam is extending over that support. A fixed support extensioning the cantilever portion, right, due to the fixity. Other than this, if it is a hinged support is there at that point of the extension, then it is known as a simple support, or it is a overhanging portion, then it is a single overhanging portion or double overhanging portion. So if the hinged end is there, then we call it as a overhanging portion. If it is a fixed end is there during that overhanging portion, then it is a cantilever overhanging portion, right? So see the figure, it is a single overhanging beam. If beam extends beyond its supports on one end only, this is the important word, it should be extend on one end only. If it extends on one end only, then it is known as single overhanging beam, right? So see the figure, it extends only one side, right? So this figure is a single overhanging beam. This side it is no extension, only after this support only it is extending. So this is the example for the single overhanging. After one side it is going to be extending. This is the overhang cantilever. You see this is a fixed end. You please notice here, this is the fixed end. This is the fixity is given here and overhanging is there. So hence it is a cantilever beam type of overhanging. Hence we can say it is a overhang cantilever, because due to this continuity, this is a continuity, there is no break. So it is not only fixed by itself here, but it is also having the continuity. Hence it is taking as a term of overhang, and being a one side fixed, then we generally call it as a cantilever. Hence one side it is a fixed, it is right, hence it is a cantilever. But this fixity having the continuity, hence we are saying it as a overhang. So overhang cantilever. Double overhang beam, where the if beam extending beyond its support on both the ends, then it is known as double overhang beam. So you see that here the beam is having the supports, one here, support two here. It has both the supports. So support 1 and support 2. So support 1 is having some extension of the beam, and for the support 2 also it is having the extension of the beam other side also. Hence this is the situation, then we call it as a both ends are extending beyond its support, hence it is a double overhang beam. Overhang beams are generally have a problem with the rotation at support. So you can see, you can understood due to this is act like a cantilever, hence it gives the rotation here. So this support is subjected to rotation, and similarly this support is also subjected to the rotation by this moment. So 15 to this particular distance, perpendicular distance, you obtain the moment here, and 30 into this perpendicular distance you can obtain the moment here. So supports are getting to the rotation at this rotation problem, or they are under moment, extra moment in addition to the force. So that is the problem with the overhang, hence we need to design for that moment. This is an example of double overhang beam. You can see here, this is the support, behind this it is extended, and here also some support is there, and beyond also it is extended. So double overhang beam. Into the last type of the beam, a beam strengthened by using the cable or rod to form a truss. So rod, if we are using the rod, you can see here there are n number of rods. This is the rod, this is also a rod, a steel type. Earlier we have seen that there are steel sections which are having different shapes. Rod like L section, T section. So you can also use the L sections. Similarly, you can also use the T sections. You can also use the H sections. Those are different type of the steel sections. You can also use the rectangular hollow sections. So we are also came across these type of sections of the steel sections. So those steel sections can be braced at the different points to form a joint. So by adding those all elements, you can frame a beam. Instead of RCC beam, you can frame a steel beam by using the a simple structural steel elements of different shapes. So this is known as a braced truss beam. There are number of shapes by using the shape of the arrangement of these sections. We can call it a different truss beam names. So for this, it is a braced truss beam. So it is a using of the components of the steel sections available in the market. So this type of arrangement is a rigid structure. It can be used for the rigid structures, and those are connected at a point of two force members. At each joint we are going to connected the two members or three members, like that. You can join a three members also, but it gives more rigidity also. So hence it requires a bracings are become a part of the beam, right? So this type of arrangement is known as truss beam. So today we also wanted to understood about the loads, as we are come across about the all the types of the beams that are we covered different types of the beams, in which these are the total beams we are covered. A simply supported beam having different types of conditions with respect to hinge and only roller supports, like that. And cantilever beam we understood, then fixed beam is covered, then continuous beam also. And we also discussed about the what is a overhanging beam and its sub classifications, including the overhang cantilever type and additional beam, that is a truss beam. So this is the total understood about the beam. Actually, we also understood that beam is supports the loads. Beam takes the loads and distribute the loads. For what purpose we are constructing the beams? An horizontal member which is primarily intended to resist the lateral loads, and secondary it can also resist the parallel loads if the supports are permitted. So this type of definition we are already studied, that it can take the loads and distribute the same to the its attachment supports. So so we need to understood the loads about also. So what are the different types of the loads, and we need to come across those loads. So the force exerted on a structural component are the burden on the element due to its self-weight, or weights due to some other element, which are movable or immovable. So you please understood that the force exerted on a structural component. So if I say what is the structural component here, you please understood this entire luggage is going to be borne, that should be bear by the these wheels only, right? This wheel is under pressure due to these loads, the weight of the body of the truck, the weight of the driver, the weight of the these load packages, or any something material which is kept in the empty space of the truck. So those weights are to be bear by the wheels only. How the wheels are going to be bear? So they are some axle between the two wheels. In between the two wheels of the other sides, it has some connection like this. So the loads are distributed through these bearing stiffeners to the axis, and due to that axis, again the load is going to be distributed to the earth or this ground or the roads. So this is the distribution of the loads which are on the lorry or truck. So these all loads are not a similar loads. You see the driver is always sitting at one position, hence its weight is a single load. Whereas these packages are also at the same point, their location might be uh, 10 to 20 mm. It might be changes from time to time due to braking system and some obstacles while traveling on the road. So it might be some up and downs and some displacement of the loads. So this displacement is also gives us some moving portions. So generally this is considered as a self-weight loads only, rigid loads only, at a point loads we are considering. But what about the movement acceleration, where the vehicle is moving on the road? So it has a speed control. When it has the speed control means, due to that slow speed and heavy speed that changes, some acceleration develops. So it introduces the force on the tire and between the road. So these forces are also accountable while moving the truck. So under the motion of the truck, these acceleration forces are also comes on the road surfaces. So the road surface has to bear these acceleration loads, and in addition to these all vertical loads are also be distributed to the road surfaces. Hence there is a dual action. One is a constant loads or point loads. We can say it is a point load or concentrated load or self-weight loads are to be directly distributed, and the indirect loads such that the acceleration load are due to the motion of the body. The vibration loads are should also be transferred to the roads or the earth surface. So it includes these all forms of forces is known as the burden on the element due to its self weight or due to some other elements which are movable or immovable. So the loads or actions are forces, deformations or accelerations applied to structure compounds. So what we can say, loads are actions. We are saying that loads are not only the simple things, they are the actions. So they are acting as a actions which are brings the structure into unstable condition in the form of, those actions are in the form of forces and deformations. You understood that it is a subject to deformations. If initially our structure is like this, after the loading conditions, if my structure is like this, it has the two supports like this, due to some different types of the loads, what happens to my structure? So there are n number of forces in different directions they are acting, and there might be some moment also, there might be some momentums also. Due to this, what happens to my structure is undergoes to the deformation. That means it changes its shape. It takes some curved shape, or it can take also some undulation shapes also according to its loading conditions. So this type of change of shape is known as deformations, or it might be subjected to accelerations. That means some jerking at this point due to the loads. So now at certain point it is straight, now it like tint, it takes some tint and goes to the up and down like that. So this deformations at the point of where the mobile uh, forces are came, where the acceleration forces are also introduced, due to that tint will be forms. So these effects of loads on the structure elements causes stresses. They introduces the stresses. They introduces the deformations. they introduces the displacement. So you please understood that displacement is also understood. That means the position of the support can be displaced by these huge forces. So this might be the support can be inclined after the loads, right? It changes its alignment due to these n number of forces. And in addition to that, it undergoes the stresses might be a compressive stress and tensile stress, like that. The reduction in the length can also be happen, and the extension in the length can also be happen. So these are a direct effect due to the loads on the structures. So one can understood that the loads should not be taken as a small part. It is the huge part which is going to be test your structure for its intended lifetime. So the stresses are to be made within the limit, the capability of the structure. Because you please understood, మనం జనరల్గా ఒకే రోజు మిమ్మల్ని ఒక 20 కేజీల బ్యాగ్ని ఒక 50 ఎత్తమున్నాం అనుకోండి, మీ క్యాపబిలిటీ 20 ఉందనుకోండి, దాన్ని దాటి మిమ్మల్ని ఎత్తమున్నప్పుడు మీరు ఎలా ఫీల్ అవుతారు? టెన్షన్గా ఫీల్ అవుతారు. అలాగే మిమ్మల్ని 15 మాత్రం ఎత్తమన్నాం అనుకోండి, మీ క్యాపబిలిటీ 20 బస్తాలు మోయగల క్యాపబిలిటీ ఉంది, కానీ మిమ్మల్ని 15 బస్తాలని మోయమన్నాం అనుకోండి, సో యూ ఫీల్ హ్యాపీ. So in the same way, if you should not be make your structure into the stress, you need to understood the structural capability, the material property of the structure materials and their physical properties you should understood, and according to the engineering properties also be designed for the same thing. So in order to avoid the deformations and displacements. So similarly, excess load or overloading may cause structural failure. So నేను ఇందా చెప్పినట్టుగా మీరు 20 కేజీల బస్తాని 20 సార్లు మాత్రమే ఎత్తగలరు. కానీ నేను మిమ్మల్ని జబర్దస్తిగా 20 కేజీల బస్తాన్ని మిమ్మల్ని 25 సార్లు ఎత్తమని మిమ్మల్ని ప్రెజర్ చేసినప్పుడు యూ విల్ బెండ్ యువర్ నీస్ and you will might be collapse on the road by at the time of the lifting of the 22-second time. So that makes excess loading. If I load you more than what your capability, then the structure will fails. So that is the applicable to the all the structures. Hence you need to understood which type of the load and how much should be the magnitude of the load should be applied, so that the structure is in the safe condition. To avoid the deformations and displacement, the stresses are should be kept within the limit. Assessment of the effects is carried out by the methods of structural analysis. So in understood the effects of these loads, what we have to do that we should assess the effect. We have to assess their effect before constructing. We should some sketches, and on that loads magnitude and some design analysis you have to carry. So and some latest programmings like stat pro and midas, like that, so many AutoCAD, like these, some of the softwares are available for the civil engineers. With those softwares like stud, these softwares you can analyze the effects of the loads on the structure. If it gives the limits of the stresses, deformation, displacement within the limit, then the design is accepted and it can be constructed or executed on the ground. If it shows some difficulty or which is showing a huge deformations, then we can add some more beams or some more columns, so that the structure will be make it within the limits of the stresses. So we have to assess these effects, and then a structural has to be designed. So what are the different types of the loads? The loads are broadly classified as per their action, and the computation for analysis has been considered as a point load or concentrated loads. Uh, so what is the point load or concentrated load? So you can see a person like you, this is standard on a ground. This is the ground surface. Let us assume we are standard on a ground. So a person is standing on the ground. So let us assume the person is standing on the ground. So what happens to him due to his entire load? His entire load is concentrated somewhere here. Due to this, due to this is total load. Let us say he is having a 50 kg. Let us say he is having a 50 kg person that has been converted into the force. This person is having a mass of 50 kg. Now we, in terms of the weight, it is converted into newtons, right? Let I am assuming acceleration due to gravity as a 10. So this person force has been converted into newtons, hence it is equivalent to 500 newtons. So this force is acting on the ground in the vertical manner, right? So in the vertical manner, so the force is acting downward at the center of at somewhere point from here. So his entire load is concentrated at one point by his feet, right? By his feet it is concentrated at one point. Due to his feet there are two point loads are coming, and their result is at in between of these two legs, right? So this is known as a concentrated load when the person is standing, right? So if the same person, if the person is standing, then what is the load? It is known as point load or concentrated load. Point load or concentrated load. So this term is important. So many times it will comes into the problems also. And so please understood that concentrated load or a point load means the total entire load is acting at one point, at some specific point, at some specific point. In the similar case, if the load is acting like this, now you please see that a person is laid on a cot or laid on earth. He is wanted to sleep. He is getting a sleep, right? Then this person is sleeping on a bed. So how it will be looks like? So he is sleeping like this. If a person is sleeping like this, so what happens here? So he has some cot also, some headrest is also there. So due to this, what happens? How the load is coming? You see now he is on the bed with the some sort of arrangement or on the earth. Now the leg load has been coming towards like this. So leg load is applying here only, and this portion of the load is also applying here only, and knees load is applying here only, and similarly between the knees and the your junction point, so at stomach junction point are also be acting individually, a small loads like that. And your stomach load is generally huge, na? Hence it is stomach loads, and like that the loads are acting like this. It's a self weight only, it's a parts weights, his neck weight, his head weight, is entirely, right? It is the formation of the loads. So if this type of load uh, varying and distributing at some point to another point, hence it is known as distributed load. This is also known as distributed load. The load of is 500 newtons, what we see in the earlier, that has been distributed at a point at differently. So is load is distributing. If the distributed load of 500 newton is uniformly if I distributed throughout its length, then it is known as uniformly distributed load. Understood that? Please understood that if the load is uniformly distributed, then it is known as UDL or uniformly distributed load. So for this, I can say that it is the unit for the uniformly distributed load is kilonewton per meter, because it shows that we are already seeing that it is a length. The load is distributing over a length. That length is in meters, and the structure is here, that we are already seeing that the structure, and it is going to be distributed its loads point to point to point to point, right? We are seeing that this load is distributing. If that is the situation, then we can call it as a uniformly distributed load. That can be marked like this. You can see that uniform distributed load. In some cases we are saying that you can draw these type of shapes for the UDL, and we can say that if I say the length is 10, if I can say the length is 10 meters, I am saying that this length is 10 meters, and we know that the force is how much it is. When he is standing, it is a 500 newtons. When he is standard, it is a 500 newtons, right? So what would be the quantity of the UDL now? Can you express by using this unit dimensions? So this is a newton and this is the meter. I need newton per meter. You can also say kilonewton per meter, or you can also say newton per meter. You can also say newton per meter, or you can say newton per mm also. So as per your convenient, you can express that force per distance that is required. Hence in this case, the both are, one is in newton, one is in meter. So I am expressing this in terms of the newton per meter. So what I can say, 500 by 10. So simply it is, I am just writing this 500 by 10, that equal to how much it is? It is only 50 Newton per meter. So that is the denomination. So again I am writing the same thing here, just to understood yourself. What is the UDL now? 50 Newton per meter. So UDL can be represented like this. How the point load is represented? Represented in the point load is just a concentrated load, that is 500 newtons only. So a concentrated load is represented as simply in newtons or kilonewtons, right? It can be a newton or kilonewton, whereas the UDL can be newton per meter. What is the varying load? Varying load, you see that it is, if it is not the same quantity, like your head is not equivalent to the your legs weight, so then it is a varying load. So around this length, if your legs and your body makes some different weights, So like this actually, no? So due to this what happens? So this weight is not equal to this weight is not equal to this weight. Hence this varies. If you draw this one in the figure, it might be like this. These are the forces. So this is varying load. So I draw this, now it becomes like this. So this type of loads variation is known as the varying load. So it can be like this, like this, like this. So this type of loads are varying from point to point, then it is known as varying loads or uniformly varying loads or non-uniformly varying loads, right? If it is uniformly equivalent to distributed, then we are saying that is a UDL, or it can be represented as like this also, the same distance, and we are maintaining the same distance. If we are representing the equal amount, then it is a UDL, right? If this is a UDL, these two cases are UDL. If it is varying, then this is the case, that is a varying loads, right? These are also varying loads are also be distributed load, but they are varying. There is another classification for practical applications that we will see, that is the dead load. That is nothing but your self weight. What is a dead load? It is equivalent to your self weight. It is nothing but your self weight. So how much you are weighing, that is your weight. What about your movable loads? Movable loads are live load, or transit load, or imposed load. So movable loads, we are already seen that transit load, they can be moved from one place to another place. In your house you are moving, hence for your house you will become a live load or imposed load or transport load. Whereas your furniture becomes a dead load, that is self weight load, right? Environment loads like snow load in North India, maximum snow will fall on these structures. So that snow load is been taken count in the Srinagar area like that. Temperature load for our nature of the South India, where the temperature is huge, even at the Rajasthan also temperature is huge. Due to that, structures are vulnerable to deformations. So due to that effects, we have to take. And wind loads are also at some extent at some states it is huge. So that consideration according to height altitudes we have to consider. Earthquake prone areas are there where the water bodies are more, and like that earthquake will like the Himalayas, and where the huge problems are there like in Gujarat. So where the that type of loads are also be taken in consideration. Hydrostatic load is nothing but water pressure, and ortholateral pressure where we want to retain some soil, then we require ortholateral pressures. And similarly, due to the constant loading, creep is coming, and due to temperatures exposes more and more, then shrinkage over the time it will come. Occasionally fire is acts on the structures, so we require stir resistance, also fire resistance. And due to some problems, due to that the foundation might be uneven, so that causes some extra loads on the structural elements. So these type of the things are also be to be considered while designing your structure. So today we are discussed about the our different types of the beams: continuous beams, overhang beams, single overhang beam, double overhang beams, and truss beam, and introduction to loads. Thank you.